So far, we learned that potential difference and current are directly proportional to each other. Now, apart from potential difference, current in a circuit also depends on the resistance of the circuit. So, in the electrical circuits of a radio, television, and other similar things, it is usually necessary to combine two or more resistances to get the required current in the circuit. Now, there are two ways of combining the resistances. We can combine the resistances lengthwise, like we can connect the resistances end to end, like the diagram shown here. You can see here four resistances are connected in series. That means end to end in a lengthwise. One end is connected to the other end. That is a kind of a combination of resistances in series. And the other way of combining the resistances is combining them in parallel. That means when you connect two or more resistances between the same 2 points. You can see here we have connected three resistances R1, R2, R3 between these 2 points X and Y. All the three resistances are connected between these 2 points and in parallel to each other. That means that combination is a parallel combination. So we can combine resistances either in a series way or in a parallel way. Now, if we want to basically increase the resistance, then the individual resistances should be connected in series, because by connecting them in series, total resistance will increase. And if we want to decrease the resistances, then the individual resistance are connected in parallel, because by connecting them in parallel, overall resistance decreases. Now, let's derive the formula for combination of resistances in series as well as in parallels. Now, let's first look at the combined resistance in series. That means what would be the total resistance, what would be the resultant resistance when number of resistances are connected in series. And definitely there would be some formula with the help of which we can calculate the resultant resistance, or we can calculate the combined resistance. Before we derive the formula for resultant resistance of a number of resistances connected in series, we should remember that when number of resistances are connected in series, that means they are joined end to end and are joined to the terminals of the battery, what happens? Each resistance has a different potential difference. You can look here. Here we have joined three resistances. We have connected three resistances, and then we have connected them to a battery, to a cell here. Okay. So what happens? Each of the resistance will have different potential difference when joined end to end, and that potential difference definitely will depend on the value of their resistance. But yes, the total potential total potential difference across the ends, that means here at point A and point B, definitely cell will suppose apply V volt of potential difference. So definitely V volt will be here, move here, and V volt potential difference will be here also. Then after traveling in this, after flowing here, resistor R1 will also take the same potential difference. Will also take the potential difference, but obviously it will take different potential. It will take some potential from this V volt. So it will take its potential depending upon its resistance. Then resistant R2 will take another kind of potential difference at its points, and this will take another potential difference. That means basically the potential difference applied by cell will get divided here between these three resistances. And after coming out from point B, you will again get the potential difference of V volts, because this V1, V2, V3, these all will get combined and come out from this point B. So that means when number of resistances are connected in series, then each resistance will have a different potential difference. But yes, total potential difference across the ends is equal to the voltage of the battery, and here that is V volts. Okay. Now, what happens when current is flowing? So, when current flow through the resistances which are connected in series, same current flows through each resistor. That means current I is flowing through this resistor. Current I will flow through R1, current I will flow through R2, current I will flow also through R3, because current will not get divided here. First R1 resistance takes current, then that current will flow here, then the same current will flow here. That means I current is flowing through the whole circuit. But yes, potential difference is different for each resistor. Okay. Now let's drive the formula. See, now here the individual resistances is for this resistor is R1, here it is R2, then R3. These are connected in series, and a battery of V volt has been applied to the ends of this series, right? Now suppose the potential difference across R1 is V1, across R2 is V2, and across R3 is V3. Okay. But the battery has applied a potential of V. So that means the total potential difference across these three resistances will be V. That means V1 plus V2 plus V3 is equivalent to V. Here I have written here V1 plus V2 plus V3 is equivalent to V, because this is the total potential difference that is applied by the battery, or you can say here cell. Okay. Now, if we apply Ohm's law for each of the resistor, if we apply Ohm's law for this resistance R1 and to find out the potential difference V1, we know that V is equivalent to IR. Now here it is not V but it is V1, and here it is R1. So V1 is equivalent to IR1. For this potential difference V2 is equal to IR2, and then for the third resistance potential difference V3 is equal to I into R3. And let Rs be the total resistance through the whole circuit. That means the combined resistance, or you can say equivalent resistance. Let Rs be the equivalent resistance for the whole circuit. Now, if you apply Ohm's law for the whole circuit to find the potential difference for the whole circuit, that would be equal to V is equivalent to I into Rs. V is the potential difference for the whole circuit that battery is applying. Current I is the current flowing through the whole circuit, and Rs is the total resistance, combined resistance in the circuit. And see, V is equivalent to V1 plus V2 plus V3, because potential difference, total potential difference is sum of all the three. Okay. Now use the value for V. V is equal to IRS, so we substitute IRS for V. Then use the value of V1, that is IR1 here. So we substituted IR1. Then for V2 it's IR2, and for V3 it's IR3. Now IRS, keep it as it is. Here I is common, so we write it here. Then R1 plus R2 plus R3. And now I will get cancelled out, and you will get Rs is equivalent to R1 plus R2 plus R3. That means the sum of all the three resistances is equal to the total resistance, is equal to the equivalent resistance of the whole circuit. So this shows, this drive is the formula for the combined resistances in series. So that means the combined resistance of any number of resistances. Here we are having three resistances, but it's not necessary only we are having three resistances. We can have n number of resistances. So whenever we are combining any number of resistances in series, the combined resistance is equal to the sum of individual resistances. That suppose if this is having 2 ohm resistance, this is having 4 ohm, 2, 4, and this is having, say, suppose 6 ohm. So if you want to find the total resistance, then you have to sum these individual resistance, that is 2 plus 4 plus 6, and that would be 12 ohm. So the whole circuit will have the resistance of 12 ohm. That is what the formula for combined resistance in series says. Now let's look at the combined resistance when resistances are connected in parallel. Now see, same thing happens here also, but let me remind you here some important points. In case of series resistance, potential difference across each resistor is different. But what happens when resistances are connected in parallel? potential difference across each resistor would be same. That means the potential difference across each resistor will be the potential difference applied by the cell. So here cell is applying potential difference of V volt. That means R1 will also have the potential difference of V volt, R2 will also have the potential difference of V, and R3 will also have the potential difference of V volt. So potential difference is same. But what happens in current? See, as the current reaches at the point A, current has to go through all the three resistance. So that is why current gets divided here. Some portion of current, some part of current will go through this resistor, some part of current will go through resistor, and the rest will go through this resistor. And after coming out from this point P, all the currents will get added up to the current equal to the whole circuit. That means if current I is flowing here, some part I1, I2, I3 are going through these resistances, and then I1 plus I2 plus I3, that is equal to again I, that comes out from the point B, right? So I is equivalent to I1 plus I2 plus I3. Now, if we apply Ohm's law for each of the resistors, but for current, so we will have I is equal to VR as per Ohm's law. So here I1 is equal to V by R1 as per Ohm's law. I2 is equal to V by R2 because here we are having it's for this resistor, and I3 for this resistance is equal to V by R3. Now, for the whole circuit, if we need to find out the current for the whole circuit, I, that is equivalent to V, potential difference applied by a cell, and the combined resistance. And say suppose the combined resistance, the total resistance in the whole circuit is Rp. That's the resistance in parallel. So V by Rp. Now I is equivalent to I1 plus I2 plus R3. Substitute the values. For I, we are substituting V by Rp. For I1, we are substituting V by R1. And for I2, it's V by R2. For I3, it's V by R3. We will, V is common here. So V will be written as this. Then 1 by R1, it's left with 1 by R2 and 1 by R3. V will get cancelled out. And we are left with 1 by Rp is equivalent to 1 by R1 plus 1 by R2 plus 1 by R3. So here you can see it's not Rp, it's 1 by Rp. That means the reciprocal of the combined resistance. And this is 1 by R1. That means the reciprocal of this resistor. The reciprocal of this resistance. That means the reciprocal of the combined resistor of any number of resistances connected in parallel is equal to the sum of reciprocals of all the individual resistances. So when we have to find the resistance, combined resistance in parallels, we need to find the reciprocal of individual resistance, and after finding the reciprocals, then add them up, and you will get the reciprocal of the combined resistance in parallel, and with the help of that you will get the resistance in combined resistance in parallel. So you can see here in series it was sum of individual resistance, and it is in parallels it's reciprocal of individual resistance. So it means definitely the reciprocal of resistance will give us the lesser value, and the sum of individual resistances will give the more value. That means the resistance in series is more, combined resistance I'm talking about, and the combined resistance in case of parallel it's less. So that is why when you have to increase the resistance, you need to connect the appliances in series, and when you have to decrease the resistance, you need to combine them in parallels. Okay. Now that means when designing an electric circuit, we should consider whether a series circuit or parallel circuit is better for the intended use. That means if you want to design some circuit for your home, so you need to check whether the series circuit is good or the parallel circuit is good. So basically we are going to see the advantages of parallel circuits in domestic and wiring, and whatever is the advantage of parallel circuit, that is the disadvantage of series circuit. So basically we are studying both of these things here. Now what happens in case of parallel circuits? If one electrical equipment stops working, electrical appliance stops working due to some defect, then all other appliances keep working normally. That means if you have connected number of bulbs in parallel circuit and one bulb gets fused off or it glows, all the remaining bulbs will keep glowing. That means one defect of one will not affect the working of others. Rest of the bulbs, rest of the circuits, rest of the appliances will work normally. If one of the bulb or if one of the appliance has some defect, it's in case of parallel circuit. But it happens opposite in case of series circuit. If one electrical appliance stops working due to some defect, all other appliances stop working in case of series circuit. Okay, because there we are joining the appliance end to end. That means if one of the bulbs suppose gets blown off, whole circuit will get broken, and that is why bulbs will not glow. Okay. Next is each electrical appliance has its own switch, due to which it can be turned on or turned off independently without affecting other appliances. So it means you can operate different appliances on uh, different switches. Every appliance will have its own switch by which you can turn it on, turn it off independently without affecting rest of the appliances. For instance, if you are having the bulbs and they are joined in parallel, you will have a separate switch for each of the bulbs, and due to which what happens, we can switch or we can switch on, we can switch off any bulb as per your requirement. But what happens in case of series circuit? All the appliances will have only one switch, due to which they cannot be turned on or off separately. You can't make them work separately because they are connected, they are controlled by only one switch. Then the third one is each electrical appliance gets the same voltage as that of the power supply line. What happens in case of parallel circuits? We also saw that the same voltage will move across through the all resistances. So all the appliances will work properly because they are getting the same voltage. So if bulbs are connected in parallels, they will get the voltage of suppose 220 volts of power supply and they will glow very brightly. But what happens in case of series circuit? Appliances do not get same voltage because voltage is shared there. We saw that in the derivation, voltage is sharing between the appliances. So appliances may get less voltage and they will not work properly. Next, the overall resistance of the household circuit is reduced, due to which the current from the power supply is high. See, in the parallel combination, what happens? The appliances total overall resistances of the whole circuit is reducing. Again, we saw this in the derivation of the formula, where the reciprocal of combined resistance is equal to the reciprocal of the individual resistance. That means the total resistance has been reduced, due to which what happens? More current will flow, right? So every appliance draw the required amount of current in case of parallel circuits. But what happens in series circuit? Overall resistance, combined resistance will increase, and that increases too much, due to which what happens? Current from the power supply is very low. That means all the appliances of a different power rating cannot draw sufficient current for their proper working. So we saw both advantages of parallel circuits and disadvantages of series circuit. But yeah, series circuit also have some advantages. That is, if you want to connect large number of bulbs, hundreds or thousands of electric bulbs for decorating, say, buildings, trees. During festivals, you used to do so, or during marriage functions, you connect large number of bulbs together. So then the series circuit is better, because all the bulbs connected in series cannot be controlled with just one switch, right? Sorry, it can be controlled with just one switch. Otherwise, if you are connecting them in parallel circuit, then you have to operate them independently, and that is not possible in that case. And series circuit is also safer because the current in it is very less, very small, because of its high resistance. So sometimes series circuit is also better. Thank you.